Um, 1.5 infinite limits. This is going to be pretty quick. Basically, infinite limits are vertical asymptotes. The definition of a vertical asymptote is as x approaches some number c, the value of the limit goes to positive or negative infinity. That's what 1.5 is about. Later on in the course, we look at horizontal asymptotes, and they have a definition that the limit of f of x as x approaches infinity equals some number. Well, it doesn't always equal a number. It could equal something else. But what's happening as x goes to infinity, all right? We do this later on. I think it's chapter 3 that we do this, okay? Right now, we're not worried about that. We're worried about infinite limits. So before we get started, I have to talk about, and I think he talked about it too, but I'm going to use slightly different notation to what he does, is if you have a constant, c is equal to constant, and you are dividing any constant by 0, that's going to equal positive or negative infinity. And you could work it out if you divide smaller and smaller numbers. So if you're going 4 divided by 0.1, 4 divided by 0.001, 4 divided by, and just keep getting smaller and smaller and smaller, you'll see that the value of that goes bigger and bigger and bigger. And if it gets infinitely small, you're going to get to positive or negative infinity, depending if it's a positive or negative number in the numerator. Okay, so you can do that if you want, but we're going to accept that any constant divided by 0 is equal to positive or negative infinity. All right, so the limit as x goes to 2 of 3 over x minus 2. Now, that we would say does not exist. But if I say, well, I want to know what's actually happening as we get close to 2, because I know that this is a vertical asymptote. I know on this graph at x is equal to 2, because it's a non-removable discontinuity from the last chapter, that we have a vertical asymptote. If I come from this direction, what is happening? Well, that is going to be x going to 2 from the positive side of our function, 3 over x minus 2. If I put 2 into the function, I'm going to get 0. Okay? So we know it's going to be some sort of infinity. Is it positive or is it negative? Well, what you have to ask yourself, if I come from 2 from the positive side, those are numbers that are bigger than 2. All right? So 2.5 is bigger than 2. If I put 2.5 into there, do I get a positive number or a negative number? I should get a positive number because 2.5 minus 2 is positive. So I'm going to use this notation 0 plus. So we're divided by 0, but think of it, I know 0 does not have a value of positive or negative, but for our sakes, we are going to think of it that way because we're doing a limit. We're saying what's happening as we get close to it. Is it a positive or negative number we're dividing by? We're dividing by a positive number. A positive number divided by a positive number is positive. Now, if you do it from the other side, 2 to the negative 2, I'm going to get 3 over 0. But because I'm putting in numbers that are smaller than 2, aka 1.5, 1.5 minus 2 is a negative number. So that's a positive divided by a negative. So that means we should go to negative infinity. And in fact, if you look at the graph, it looks like this. Okay? So you can see if you come from the right-hand side, you're going to positive infinity. If you come from the left-hand side, you're going to negative infinity. That's really all we're doing here. So let's have a look at, I feel like we need to do something slightly different. Let's try, I'm only going to do 2 examples here. Number 2, whoa. Limit as x goes to 5 from the negative 5 of 1 over x squared minus 25. Okay. Well, clearly, if I put 5 into that function, I'm going to get a negative number. Or sorry, a 0 on the bottom. So it's 1, and it's going to be divided by 0. Is it going to be a positive 0 or negative 0? Well, I'm coming from 5 from the negative side of 5. What are numbers that are smaller than 5? 4 is smaller than 5. If I put 4 into here, 4 squared is 16. 16 minus 25 is a negative number. So 1 over 0 negative is negative infinity. Okay? If I come from the other side, I get 1 over 0. Numbers bigger than 5, the right-hand side, 6. 6 squared is 36. That's a positive. I'm going to go to positive infinity. So I know on this graph, because, in case you didn't see it, that will factor to 1 over x plus 5, x minus 5. Those are non-removable. Cannot make them cancel, so they are vertical asymptotes at 5 and negative 5. So I'm saying what's happening as I approach 5 from the negative side, I go to negative infinity. So if I come 5 from this direction, I go to negative infinity. If I come up 5 from this direction, I go to positive infinity. The question is, what happens if we go to this negative 5 here? Well, let's see. So we're going to do the limit as x goes to negative 5 from the positive side. Okay. Again, if I put negative 5 in there, I get 25 minus 25. So it's going to be 0. Is it positive or negative 0? I'm coming at negative 5, this number here, from this direction. So just pick any number. The easiest number would be 0, but we could put negative 4, negative whatever. We'll use negative 4. If I put negative 4 in there, and you don't have to show this work, you can do it in your head. Negative 4 squared is 16. 16 minus 25 is negative. So positive divided by negative means I'm going to negative infinity. So if we come from this direction, we shoot down to negative infinity. If I come at it from the other direction, negative 5 from the negative side of 1 over x squared minus 25. Sorry, it's getting squished here. A number that is smaller than negative 5, so we're coming at it from this side. So negative 6. Negative 6 squared is 36. 36 minus 25 is positive. So we go to positive infinity. And there's your graph. That's infinite limits, people. Use this little 0, positive, negative, and remember that any constant divided by 0 is always positive or negative infinity. Your practice questions are page 88, 5, 7, 29, and 31. For 29 and 31, don't graph. You can if you really want to, but you don't need to. And then 33 to 43, odd, and 65 to 71. All right, that is pretty much the end of the unit. Tomorrow's a review. I'll post something regarding what you need to expect for your test. All right, good luck, people.